Hi everyone, welcome to Cola Teaches Math. So I had some requests from my lovely students to do something called, I call it disguised derivatives. So it's 2.2 if you're following the CED. And it's basically, we're using the definition of the derivative. So I have both of them right here to find the derivative of something. So the reason I call them disguised is because it's not saying like find the derivative. You have to understand that if I give you a question like number 1, they want you to find the derivative. Now, what gives it away? Look, compare it to the difference quotient. So this is what I teach my kids. First thing I teach them is look at what's in place of the x. Make sure it matches and throw an x over it. So step 1, put an x over it. The number, make sure it matches. Step 2, the function is what follows the subtraction sign. So I say, okay, let's identify the function. Next, we're gonna take the derivative. This is telling me to take the derivative. So now we're going to derive cosine to be negative sine. And then what it wants us to do is we're going to take the derivative and we're going to plug in pi over 3. So we need to find negative sine pi over 3. So that's going to be negative. Now the sine of 60 is going to be rad 3 over 2. So this would be the multiple choice answer. Look at this one. It's slightly different. So I'm only doing questions like that look like the left because that's what I put on my class's test tomorrow. You could look at some other ones that look like the alternate definition of the derivative, but right now we're focusing on the left. So look at this. This one's interesting. Now, do you see how this is sine x plus h minus 1? So now where did they get this 1 from? Well, check it out. Instead of writing 1, I could write the sine of pi over 2, because the sine of pi over 2 is 1. So the 1 comes from evaluating the sine of pi over 2. So if you'd rather me write it, I can rewrite it like this, because I've seen questions like this before. So they would write it like this if this helps you guys, because then we can use my trick. My trick is make sure the numbers match, throw an x over it. This is the function, so step 1, identify the function. Step 2, take the derivative of that function, cosine. Step 3, plug whatever we threw the x over in. So we threw the x over pi over 2. So now it's going to be the cosine of pi over 2. Visualize that in your head. That's going to be 0. All right, this one is a tiny bit different because do you notice how I don't have anything in place of the x? So if I asked you to take the derivative of this using the definition of the derivative, everywhere you see an x, you would replace it with x plus h. That's what they're doing over here. They're doing f of the function evaluated at x plus h. So the function, step 1, is 2x squared minus 2x plus 1. Step 2, take the derivative, 4x minus 2. Notice how I didn't plug anything in for x? So then this is done. This is all it wants. It wants a general derivative. Okay, last one. You see this one? Once again, where did this 4 come from? Well, check this out. If I had you guys, let's look off to the side. Take the derivative of this. Okay, watch me. 3x squared minus 4x, the long way. You would do the limit as h approaches 0. Everywhere you see an x, you would replace it with x plus h. Minus the function. So the function is 3x squared minus 4x all over h. That's how you would find the derivative. Well, it kind of looks like this. This 4 comes from this function. So look, the function is 3x squared minus 4x. Do you notice how I put a 2 over the x right here? Because this is x plus h. X plus h. So now let's see if I plug in 2 for x, do I in fact get 4? Let's see. So that would be 12 minus 8. We do get 4. So that's where the 4 comes from. It comes from me evaluating the function at where I'm asking you to take the derivative. Look up here. This was 1 came from me evaluating the function at pi over 2. So this comes from me evaluating the function at x equals 2. So step 1, the function is 3x squared minus 4x. Step 2, the derivative is 6x minus 4. And step 3, evaluate the derivative at 2. 6 times 2 minus 4, that's 12 minus 8 is 12 minus 4 is gonna give me 8. Okay, so those are disguised derivatives.